Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem. So first of all we are going to do a solution searching, and also we are going to do some coding work. And the second goal is to see how we should behave in a real interview. So let's get started. So in the real interview, remember the first step is always try to understand the problem. If there is anything unclear, please bring up the question, and also at the same time think about some edge cases. So let's take a look at this question. Intersection of three sorted arrays. So given three integer arrays, array 1, 2, and 3 sorted in strictly increasing order, return a sorted array of only the integers that appear in all three arrays. So example 1, we have array 1 to 3 here, and output is only 1, 5, because only 1 and 5 appear in all the three arrays. So let's see some constraints. So every array, the length of every array is between 1 to 1000, and the number within the array should be within 1 to 2000. Okay, so I think it makes sense, and I don't see some very clear edge cases because each of the array is going to be non-empty. So let's think about how to find the solution. So how to solve the problem? So first of all, a very obvious solution is to have a hash map. To the hash map, the key is the integer and the corresponding value is a frequency, and we go through every number within the array, try to update the number and the frequency in the hash map, and finally we will iterate through the hash map and see which number has frequency as 3. So for that one, the runtime is going to be linear to the sum of the length of all the three arrays. And the space-wise, it could be also similar, like linear to the length of all the three arrays. Let's see if there's any better solution for us to save some space. So let's say if we have three pointers that pointing at the very beginning, the 3 pointers point to the index of the three arrays. So let me give you an example. So let's say this is array 1, 2, and 3. We have 3 pointers, and let's say this is P1, and this is pointing to P2. This is P3. So at the very beginning, all the 3 pointers start at the beginning of each of the array, and we will do the comparison to see if the number is inline among all the 3 arrays. If yes, then we just need to proceed everything to the right by 1. Otherwise, we will just proceed the smallest, the index pointing to the smallest number to the right by 1. So in this case, we are just going to proceed P1 by 1, and it is not inline, then we are going to move P2 to the right by 1. And then we see that it's still not inline, then we are going to move P1 by 1 because it's pointing to 3, which is the smallest. And currently, next time we are going to move P3 by 1, and then this time we are going to move P1 by 1, and then we are going to move P3 by 1, and we see that another number 5, and we add it to the result list, and then we are just going to move P1 by 1. So on and so forth until any of the pointers run out of the range. So the runtime for this approach is going to be all of n, and space-wise is going to be all of 1. So having said that, let's get started and do some coding work. So for coding, we care about the correctness of the code, the readability of the code, and of course, the speed is also a concern. So let's see. First of all, we have the integer array as the intersection, new linked list. So we're going to say, okay, we have 3 pointers in P1 and P2 and the P3, and it's like, well, P1 is smaller or smaller than array1 dot length, and P2 is smaller than array2 dot length, and P3 is smaller than array3 dot length. So we are going to say if array1 P1 is equal to array2 P2, and array1 P1 is equal to array3 P3. So that's the time we encounter a number that exists in all the three arrays. So we are going to have intersection dot add the array1 P1 and move all the pointers P plus P1 plus C2 plus C3, and otherwise, and then we are just going to continue. Otherwise, there is some place that has misaligned line. So we are going to say we need to find the index that is pointing to the smallest number. So let's say the smallest num as equal to array1 P1, and int so let's say which this is the smallest number, and we need to decide which one to move. So this is the smallest one, or we could actually have an array, which would be simpler actually. Let's say P is new int 3. So in this way we would just say this is P0 P0 P1 P3. So you use that way to represent the pointers. So it is then P0, this is P1, this is P0, this is P2. So something like that. So this is P0, 1, this is the 2. Alright, so now we have the smallest number and the smallest IDX as equal to 0. So if ARR2, this is P0. So if ARR2 P1 is, if it is smaller than smallest num, then you're going to have the smallest IDX as equal to 1. And if the ARRP2 is smaller than smallest num, then we are going to have smallest IDX as equal to 2. And then finally we are going to plus P smallest IDX. Yes, and then finally we are just going to return intersection. Okay, so that's pretty much it about the coding. Let's do some testing. So we are going to go through an example to explain this piece of code, and also at the same time do some sanity check about the logic. So let's use this example 1. So first of all, everything is pointing to this is P0, this is P1, and this is P2, and we have the result. So at the very beginning, 1, so all the first numbers are 1, so we are going to add 1 into the intersection and then proceed all the indices. And then we have the smallest number as everyone p0, which is 2, and we see that the smallest index as equal to 0. And after the comparison, we don't see anything smaller than 2, so we are just going to proceed p0. And similarly, next time we are going to proceed p1, so on and so forth. So I think overall it should be workable. Let's give it a shot by running this piece of code. So it is array1p. Okay, so I forgot to change this one. Intersections. Okay. Intersections. Okay, so let's fix this typo. So it is array. This is array 2 p1. This is array 3 p2. Okay, so intersections. Alright, so after fixing all the typos, I think it should be good. Let's give it a submission. Yeah, so I think everything works well now. So that's it for this coding question about the solution. If you have any question about the puzzle or about the solution itself, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.